Okay, today we're going to be learning about multivalent ions or multivalent metals. So let's break down what that word means. So multi, we know, means more than one, and valent refers to valence, which are the types of electrons that are our outer electrons, and they're the ones that determine what kind of ion you're going to make. They're the only electrons that can be lost or gained. The types of things that are multivalent are metals that are called transition metals. So go to your periodic table. This section that I've highlighted here, these B groups and these ones under the staircase, they are where you're going to find your multivalent metals. You might have a periodic table that actually has all the charges on it. And you can see here that there are multiple charges. That's going to create a little bit of a problem. Let's look at an example. Let's take copper. There are two possible ions for copper. There's copper with a 1+ charge, and there's copper with a 2+ charge. So let's say we wanted to combine copper and chlorine. Now, chlorine is a nonmetal, and it always has a -1 charge. So remembering the rules we had for ionic compounds, if I were to put these together, you can see that this is losing 1 electron, this is gaining 1 electron. And so your formula will be CuCl. However, this one wants to give away 2 electrons. Chlorine can only take 1, so I would need another chlorine. And so I would have the formula CuCl2. So if I were to name these the way we were naming before, with the name of their metal, and then our nonmetal would be called chloride, I would have a problem. How do I know if I'm using copper chloride, if it's this kind or this kind? So we have to have some new rules. A long time ago, there were different suffixes that were used. So you would use different endings. So there's cuprous and cupric, and it was kind of complicated because not every multivalent metal has the same types of charges. And so you had to memorize all of it. So we have a much more convenient way today. What we're going to use is Roman numerals. You may or may not be familiar with Roman numerals, and if you're not, Roman numerals are I's for ones, V is 5, and so 4 is actually IV. So think of it like 5 take away 1 is 4. If I had 6, it would be VI. It'd be like 5 plus 1. So we're going to use Roman numerals, and the Roman numerals are going to tell you the charge. So this copper would be called copper, and then we're going to use brackets and a Roman numeral 1. This copper, which has a charge of +2, we would use the Roman numeral 2. If something had a charge of +3, you'd use the Roman numeral 3, etc., etc. So the name of this copper chloride would be copper 1 chloride, whereas this one would be copper 2 chloride. Now, we only use this system when they are multivalent, and there are a couple transition metals down here that always have the same charge, and you do not require to have a Roman numeral. So one is silver, which is always +1, and then there's zinc, which is always +2. So you do not need to use Roman numerals with silver or with zinc. So let's just do a couple examples before you try some of these on your own. So we want to be able to write formulas from names and names from formulas. So let's look at iron 3 oxide. How would we do this? So the first thing you would do is you would look at this. You would go to your periodic table and look for the formula for iron. Now, because it has a Roman numeral, we know it's multivalent, and multivalent will only be in this section here. Iron has one of those funny symbols. It stands for ferrous, so Fe is the symbol. So I'm going to write Fe, and Roman numeral 3 means it has a +3 charge. And then the oxide, we know that we use IDE endings from things on here. We know that that has to be our nonmetal because that word came last. So that's oxygen, which is here, which is O, and it always has a -2 charge. So now I know what charges I'm dealing with, and you can then use one of the methods that we learned about before to decide how you're going to put this formula together. So you might visualize it. This is losing 3 electrons. This can only gain 2 electrons. And so you could do your little drawing. You could do it sort of mathematically. We know that the number of electrons lost have to equal the number of electrons gained. So I don't have enough over here or over here. So in order to have the same amount of positive and negative charges, I would need 2 of these. I would need 3 of these. Or you could just simply use the swap and drop method. Either way, you're going to find out that the formula would be Fe2O3. Now, how do you actually write the name if you have a formula? So let's look at a different example. All right, SnCl4. So if I saw this, the first thing I would do is I would look to see what is the name of the element with the formula Sn, and that is tin. I would see that tin is in that special group. It's under the staircase. And I could use a chart if I wanted to see what my options are, but I can just simply use what I know about charges. Now, Cl is chlorine. And from my periodic table, chlorine is always -1. There are 4 of them. So that means that there would be a total negative charge of -4. I know that the charges have to equal. The number of electrons lost have to equal the number of electron gains. So if this would have a total charge of -4, this would have to be +4. So this would be tin, a Roman numeral 4, chloride, remembering my IDE endings. You could also sort of use that swap and drop. I know that if I were thinking about this is an imaginary 1 on the tin, and I have a 4 on the chlorine, those charges are swapped. So this would be a +4, this would be a -1. And I have to use the Roman numeral because this is multivalent. So I hope that helps. And now you should practice your worksheet. And just remember the 2 exceptions, silver and zinc. They do not require a Roman numeral.